Now, we've talked a little bit about circle theorems in previous sections, and we're going to dive a little bit more into detail about those. And we've seen some of these relationships before. So arc length, sector area, and central angle, we are familiar with those. Again, sector area, think about them as like pizza slices on the circle. And we see this proportional relationship that we have here, central angle to angle measurement, arc length to circumference, as well as sector area to circle area. And we've explored some of these a little bit before. So let's utilize these in a couple more examples just to kind of reinforce that. So in the figure O, the center of the circle, the area of the circle is 16 pi. We want to find the area of the shaded region. Well, we've done this before. We know that we can set a proportional relationship. Here we're given the measure of the angle O. And so we know that it is a 90-degree angle related to a 360-degree rotation. So that is the central angle compared to a full rotation of 360 degrees. And then what we want to do is we want to look at the area. Well, the sector area will be proportional to the circle area based on this proportional relationship. So we've got our central angle of 90 with a full rotation of 360. We know the area of the circle is 16 pi. We just want to find the area of the sector. So using a proportional relationship, we can simplify this ratio. We know it's going to be a 1 to 4 equals x over 16 pi. And so we can solve this as 16 pi equals 4x. Therefore, x equals 4 pi. And so we know the area of the sector is 4 pi units squared. Here we have another circle. In the figure, point A, the center, and the length of arc BC is 3/10 of the circumference. And so they've told us this ratio of arc length to circumference. It is 3/10. We want to find the value of x. Well, x is the measure of the angle. So if the arc length that is formed is 3/10 of the circle, then this angle is 3/10 of a rotation. So we set up our proportional relationship, and then we can go ahead and solve. We multiply both sides of our equation by 360. We get 360 times 3/10 equals x, which means that x equals 100 degrees, or x equals 108 degrees using already there. We finish up with some more angle relationships within our circles. So something to consider that any triangle formed by two radii of a circle must be isosceles triangles. And so we see that these points here and here are both the radius, and they have to be equal in length, meaning that the angles are going to be congruent here and here, and we can use that information to our advantage. So in the figure O, is the center of the circle, we want to find the value of the angle x. So in order to do that, we first have to find the measure of the angle O. Well, given that AO and BO are radii, they have to be equivalent in measure, which means the angles that are opposite are also going to be equivalent in measure. So we know that this angle measures 50 degrees. Well, the sum of the interior angles of a triangle has to add up to 180. So we know that the measure of angle O plus 50 degrees plus 50 degrees has to equal 180. Therefore, the measure of angle O has to equal 80 degrees. Then we can also go back to our circle and look and see, well, if this is 80 degrees and one full rotation is 360 degrees, the difference gives us the measure of angle x. So x plus 80 has to equal 360. So x has to equal 280. Here we have two isosceles triangles that are drawn. And so O is the center, which means this is a radii, this is a radii, this is a radii, and this is a radii. So all four of these sides are congruent in measure, which means that this has to be 35 degrees, and this has to be 35 degrees, and this has to be 35 degrees. All of those angles have to be 35 degrees. Therefore, the value of x is 35 degrees. This last problem, again, we have a radii, and we have another radii. And so we know that these two sides and this one all have to be congruent. Well, if we have an isosceles triangle here, and we know the measure of this angle is 25, we know the measure of this angle is also 25. So we can find the measure of this interior angle. We know that the triangle sum theorem, that 25 plus 25 plus the measure of that angle, let's call that angle y, has to equal 180. So when we subtract, y is 130 degrees. Well, y is supplementary to angle x here, so we know that angle x plus angle y also has to equal 180 degrees. Well, if angle y is 130, then angle x has to be 50 degrees. And that wraps up our geometry and trigonometry section of the SAT. Again, this is a very basic introduction and surface level to some more of these advanced concepts that we will explore later in our school year, but this should get you through most of what you would need as far as these types of questions appear on the SAT.